हाय गाइस, वेलकम बैक अगेन माय व्लॉग। और आज का ब्लॉग बहुत ख़ास है क्योंकि आज आईआईसी के तरफ से बहुत बड़े वैज्ञानिक आ रहे हैं जो इंडिया के बहुत यंगेस्ट साइंटिस्ट है और उन्होंने आदित्य एल1 में अपना योगदान भरपूर दिया है। तो आज सीयूएसबी में आईआईसी कमेटी के तरफ से डॉक्टर बलवीर सिंह जी आ रहे हैं। तो उनके उपलक्ष्य में हम लोग ने रंगोली क्रिएट किया क्योंकि वो आज हम लोग का लेक्चर के माध्यम से ग्रह, उपग्रह, नक्षत्र और अंतरिक्ष में होने वाले बदलावों के बारे में बताएंगे। आदित्य एल1 के बारे में, मॉडर्न ज़माने में कैसे उपग्रहों का निर्माण हो रहा है, कैसे मिसाइल, सैटेलाइट बन रहे हैं, उसके बारे में बताएंगे। फिजिक्स के बारे में बताएंगे। तो इसलिए उनके उपलक्ष्य में हम लोग ने बहुत अच्छा एक रंगोली क्रिएट किया। उस रंगोली को जब उन्होंने देखा तो बहुत तारीफ़ किया। मैं तो अब ओवर वॉइस कर रहा हूँ, आइए उनकी बातों को सुन।
The Sun is a massive sphere of plasma where nuclear fusion continuously releases energy, powering life and influencing space weather across the solar system.
With modern missions like Aditya L1 and Parker Solar Probe, scientists are now studying the solar flares, coronal mass ejections, and magnetic storms with unprecedented precision. And I am Aditya Kumar Singh, and we are delighted to be your hosts for today's session.
We are truly honored to have with us today an eminent solar physicist, Dr. Balveer Singh.
Dr. Singh holds a PhD from IIT BHU, Varanasi, and is a fellow of the Royal Astronomical Society, London, a prestigious recognition in astronomy and space science.
Currently serving a postdoctoral research assistant at the University of Dundee, United Kingdom, his research focuses on solar atmospheric physics, magnetic field dynamics, and solar wind processes.
To formally welcome our honored guest, we now invite the President of IIC, Professor Venkatesh sir, to kindly felicitate Dr. Balveer Singh.
Journey and contribution of esteemed guest speaker, I invite Joint Secretary of IIC, Shivangi, to briefly present his profile and kindly call Dr. Balveer Singh for his lecture.
Venkatesh Singh, President of IIC, esteemed guest speaker Dr. Balveer Singh, honorable faculty members and dear students, a very good afternoon to everyone. On behalf of the institution's Innovation Council, Central University of South Bihar, it is my privilege to warmly welcome you all to today's lecture on probing the sun and space with modern space observatories. It is my great honor to introduce our esteemed speaker for today's session, Dr. Balveer Singh, an accomplished solar astrophysicist and a distinguished fellow of the Royal Astronomical Society, London. Dr. Singh completed his PhD in solar astrophysics from IIT BHU in 2023 and is currently serving as a postdoctoral research assistant at the School of Science and Engineering, University of Dundee, United Kingdom. He has also made significant contributions to India's first solar space mission, Aditya L1, through the Aditya L1 Support Cell, a collaborative initiative of ISRO and Ares, Nainidal. His research expertise spans solar jets, waves, the sun's global magnetic field, and major space weather events such as solar flares, coronal mass ejections, and solar wind. Utilizing advanced observations from missions like Parker Solar Probe and sophisticated computer simulations. In addition to publishing numerous research papers in reputed international journals, Dr. Singh has been actively engaged in scientific outreach, delivering insightful lectures on plasma processes in the sun's atmosphere and space weather phenomena. We are
It is good or my voice is clear over the net?
Okay.
Okay. So we need to use this one or not? Okay. I just because the country and our solar community, not only the solar community, all astrophysics community wants to, for the mind, because because we need to clarify the more science in era of high resolution of projections, because the technology is currently developing, and we have a very good facilities as per like space-borne observatories as well as the ground-based observatories. So many of the people are already know about the ground-based observatory during the era of the Britishers. And second thing is, why we are talking about the space and sun or moon or whatever the space mission. The first thing related to the talking about always the space and sun. The first thing is related to motivate all of you, because without motivation you cannot perform. You cannot join our space kind of research for the sun, moon, and other space observatory for the youngest mind, because I have suffered with such a problems when I did my masters from different universities, and before joining the PhD we don't have any idea about what is the how people are performing the research in field of the space and sun and moon, because this is very critical field, including because the researchers are using the particular processes on our daily life on the earth. And space, because we are suffering with the cosmic rays, so sometimes we need to refine our ideology, our basic concept about the space, so how we can understand deeply about the space, because some radiations comes from the space, so we need to study deeply about that radiations, because that radiations sometimes hits on our power grid communication system as well as our satellite system in space. And sometimes if you have already heard about the space traveler who were going to space and spend some time in the ISS, International Space Station. So recently Indian people Sudhanshu Shukla as well as his team is returned back from the ISS. So without deeply study about the space radiations, so astronauts is not surviving there. This particular point I cannot use this pointer. You can see here the sun is here. I mean the entire solar system is here. So we are existing is just like a small teeny body, just like teeny body, just like a particle in our galaxy. This is not a real image of our galaxy. This is the synthetic image. Synthetic image means the spacecraft, or you can just take some pictures from different angles and then combine all the pictures and make the synthetic image. Because we cannot take the direct picture of the Milky Way galaxy, because we are inside the Milky Way galaxy. Suppose you are inside in the room and you cannot take the full picture of this room. So the idea is about how we take the full picture of the galaxy. Why we need to take full picture of the galaxy? Because we want to just elaborate more about where we are. You have a different type of cameras. So camera is just taking the picture with the very low resolution. So you can see here the picture taken by naked eyes, and different the difference between the digital camera. So we cannot not notice about what the cosmic object is there. Even in the era of Copernicus, in the era of Galileo, so they were used the naked eyes to detect what happened on the sun, but they were fake. The NASA as well as other space agency, European space agency like Russian space agency, initially started the space missions as well as moon mission. Basically they were success landing on the moon, like you people already know about the Apollo mission, Apollo 11, whatever the successful land on the moon. Some people got the some different news about the Apollo missions. So at that time in 1962, so 1962 when America was prepared to launch their space satellite and try to landing on the moon. So at that era, the Indian space program was started from a very small town. So I want to show just the people are coming from the small town, and something imagine, people can imagine I am from a small town, so I cannot do anything. So you can imagine just the Thumba is in Kerala. Thumba is a village, very small village, not developed fully, still not developed fully. After 1962, we have already spending around these rockets on cycle, and the main problem was there how we can launch our satellite, because we don't have any large tower so that we can build up our rocket and we can launch. So there is no any official launch pad at that era in 1962. So at that time there was a church in Thumba village. I have visited during when I was in Aditya L1 and worked with the ISRO. So the Thumba village have a very small church, not a very large, and they have very tower. So they just fix their rocket. You can notice here this rocket. The first rocket was fixed with this top part of the church, and they launched and they got success. So that was the time when the people were knows about the space programs. So this was very small, just go to space and return back, not go to the lower earth orbit, because we don't have any radar system, we don't have any modern facility. So this church basically today is converted into the space laboratory. So I want to say to all in the minds, if physics behind the space in the lower earth orbit. So there are different satellite system launching different years by ISRO using the PSLV, GSLV and different kind of rocket. So I'm not going to talk about the detail of the rocket, whatever the GSLV, whatever the PSLV. So you can just assume people were knows about the India where launched the first satellite as a Aryabhatta satellite, because Aryabhatta was started from the study of skies, and they were observe the pattern of the sky in the various area. You people know, because you people are mostly people from Bihar and you are here, so you were knows about Aryabhatta. So these are the space programs from physics. Through this business we can understand about what the exact physical phenomena inside the stars, inside the moon, inside the whatever other object what we want to study. So in Chandrayaan in 2008, the Chandrayaan 1 was launched. It was success mission, and then in 2013 Mangalyaan, you know very well, the Mangalyaan was the Mars orbiter mission. Whatever the one module is rotating, circulating around the Mars, and they were send the data. Data means other module, whatever the circulate around the moon was success. So it was also a success mission. Otherwise Chandrayaan 3 we cannot know much more about the moon. Chandrayaan 3, whatever after lander failed, so Chandrayaan 3 in 2023 successfully landing, successfully who were go to the L1 point. L1 point is much far from here, I mean Earth. Okay, and then Gaganyaan recently launched, and they have Gaganyaan is just like experimental things, whatever we have to send our people from here to space. So this is under observations also. So after Mangalyaan 2013, the Aditya L1 actually proposed in 2007 to the ISRO, in front of ISRO, and the ISRO people are consider how much grant you people require. So L1. So first we talk about the sun, because Aditya L1 is designed for the study of the sun. So when we talk about the sun, so in initial days the people were considered sun as a god, as people, because they were they were knows about the pattern of the sun. In the morning time sun is rising, in evening time, so they were considered about the sun is Galileo's experiment. Whatever the Galileo is designed a telescope, long telescope, around 30-meter telescope in 1600 AD, and then the Galileo were observed the sun, and then the people are using the word sun as a star. So because when we talk about the star, it means there is some physical processes happen inside the sun, I mean below the surface of the sun to the core, and some physical the small portion of the sun, there is some chunk of the plasma released from the sun's atmosphere, and it sometimes interact with our Earth upper atmosphere, magnetic field of the Earth upper atmosphere, and it may sometimes destroy our communication, navigation, as well as satellite, even our astronauts. So this physical processes makes much interesting for the researcher to study deeply in this what happened in the sun. So you can notice here the sun's energy basically generated due to the the density of any stars. And any researchers who are talking, who are working on the space and stars, So the density and temperature, these are two, you know, fundamental parameter who were, basically used by the researchers, and elaborate more about the what happened on that star. So you can notice this mass as well as the radius. So radius is around 109 times radius of the Earth. So you can assume how big our sun, and mass is around such a large volume of the mass. This one. Also other parameter whatever I am talking already about, the age is around 10.9 here. So we are suffering some black spot. This spot is noticed first time by the Galileo Galilei in 1613 AD. So Galileo was developed the telescope, and he was the first person who observed the sun's spot first time in the field of astrophysics. So this is the different pictures taking on different days. So you can assume Galileo were did around 3 to 4 years to detect the sun's spot. 3 to 4 years. Of course, the black spot is called penumbra. So physics of sun's spot is different. How the sun's spot is built up, what are the physical interaction, what are the magnetic field, other things, how the magnetic field and geometry inside the umbra, inside the penumbra is different. I am not going to detail discuss about the physics. So you can notice here the size of the sun, size of the sun's spot. Other thing like this one is called granulous motion. So granulous motion is like basically bubbling like structure on the surface. Suppose we have some small bubbles on the surface. So such a bubbling like structure is called the granulous happen on the sun's photosphere. For this umbra as well as the surrounding is the penumbra. So how is the big? How is what are the physical processes happen on the sun's spot? This is very interesting thing for the researchers, for the scientists. Other thing what I am going to talk. Suppose we are observing in a single wavelength. Single wavelength is the each wavelength related to the temperature. Basically in the physics, the wavelength related to the temperature. So both are exchange. So positive converted into the negative, and negative polarity converting to positive. It takes around 20 years to complete exchange of the any polarity. So this is the photospheric structure. Sun looks like much brighter on the limb. This is called limb of the sun, and this is basically the disk of the sun. And in other temperature mat, other temperature other filter, you can notice the bright structure. This is called sometimes coronal loops, jets. Other plasma processes happen on the sun. This is very interesting that the solar corona, basically the coronal part, atmosphere, whatever people are living about solar atmosphere. So when we see the completely all full image of the sun, so you can notice here there are some bright patches, these dark patches, bright patches. So people are trying to understand how these patches are formed, what are the impact of these patches in our space weather kind of things, and other like what impact on the satellite system and communication system at all. So you can notice here this rotation is around 27 days of the this image is taken from the probe of the surface of the sun. Okay. So yeah, so you can notice the simulation done by either Kolkata people, Devendra Nandi and team. Whatever, I am also working on such a generation of magnetic field and what the impact of that magnetic field in space weather kind of thing. So you can just notice these magnetic field lines is rotate and just convert into the polarity. So basically northern polarity converted into the southern polarity. So you can get surprised how these magnetic, this is the magnetic field line, this is not a rope. In 1995, end of 1995 in December, and it will provide the data from 1996 where the solar minima were there. So you can notice in 1996 up to the 2020, so this bright patches is increases sometimes and then bright patches is decreases. I mean there is some magnetic field happen, magnetic field polarity inversion happen start from 1996, and this brightest patches is more in around 2001, 2002, 2003. It means this is called the solar maximum, where the more activity happen on the sun. At that time, actually, that radiation is very harmful for the human being. human life. Whatever the people are coming from the life science, they know better. So such solar maxima and solar minima activity happen in every 11 year, which is called solar cycle. And when we observe the sun from long durations, you can notice there are multiple times minima, maxima, minima, maxima. This means the number of sunspots as well as the area of sunspot. Sometimes the sunspot, sunspot is very large area, very large size, and sometimes sunspot is very small size below the photosphere. So how the life is affected with respect to the solar cycle, especially sunspot or active regions. So you can notice at that time the ice era were started and the people were died, who were living in the bank of the river or whatever, and there are some war was started. So this is the physical implication of the solar minima and solar maxima. You can notice the Volga river got frozen up. So without river at that time during the 1650 to 1700 AD, the people totally dependent on the river. They cannot survive. They cannot get the sun and earth, and we can observe the entire dynamics what happened on the entire area of the sun. So when we totally block by artificial things, artificial days by the sun's using in our spacecraft. Aditya L1 have some technology to block the solar surface, even solar chromosphere, and notice the CMEs. So such a coronal mass ejection is very huge. You can notice the size of the sun is looking like this, but the CME is bigger. And Parker solar probes actually create the better, provide the data for better understanding about the sun's atmosphere. Basically, the solar winds and CME talk. So you can notice here about the solar wind. So this is the data taken from the Parker solar probes. You can see how these charged particles, these are the charged particles come from the sun. Okay, so these charged particles come from the sun. It sometimes heated on the Earth upper atmosphere. So we are trying to understand how these particles come and how these particles are more intense or not. Because without deeply understand, we cannot predict better to understand about the solar wind as well as the related plasma processes. Sun and it interact with the space. Yeah. So you can notice such a charged particles interact with such a space observatory, and it may destroy because this just body. Of course, the space is fully covered by the different kind of satellites. So some satellites are in lower Earth orbit, which is around 400-300 km above the sun's above the Earth's surface, and some satellites near the sun. So Parker solar probe is here. So Parker solar probe basically touches the outer atmosphere of the sun. So it is a much closer to the sun. So because when we talk about the much closer satellite, okay, so there are 7 payloads on board. So first one is VLC, Visual Emission Line Chronograph. The interesting thing is not in the name. The interesting thing is that all 7 payloads is designed from different institutes in India. Okay, so ISRO is responsible for the launching of the Aditya L1, but all payloads is proposed by the different scientists, different professors from the different institutes across the India. And also in ISRO laboratory there is some ensembles, integration of all the payloads and rockets and PSLV, and then they do. So basically it is spectroscopy as well as the imaging board. I mean the suit is required the spectra as well as the image also. Other, it is designed by the IUCAA. There are 3 to 4 benefits, science-wise benefit for the L1 point, because first one is that when we set launch our satellite around the L1 point, we can observe the sun into 24/7, means 24 hours, 7 days, without any occultation, without any eclipse. Suppose when moon is going in lie between the sun and earth, so you can notice one rope and just attach with one stone and just revolving around in circular and then throw with the higher speed. So just our satellite is revolving several times, 2 to 3 times, and increase the speed of our satellite. And then when the satellite increases a critical velocity, then it moving towards the L1 planet. So it is common, this fundamental rule how to launch our satellite. Direct launching of the satellite is also possible, but we need to spend much energy to direct, hit our satellite, launch our satellite from here to. So these are the points. I'm not going to detail. And yeah, when I was in ISRO project Aditya L1, so you can just see this image. This is the table image, whatever I just make the video during that time. This video also can find on YouTube. So this video is created when we have tested a small, model of our Aditya L1. Either this Aditya L1 will follow the trajectory or not. So I told earlier, each and everything is, checked 20 to 30 times in the laboratory scale, and then we launch. Otherwise, once after launching, we cannot do anything in the slide. So this is one example, and this is the instrument how we can measure. These are major goals, whatever I have already discussed, and there are several physics. So just skip, and yeah, of course. So this work is basically done by my team at UK. So how we designed our simulation for the global magnetic field, because magnetic field is play a key role for all the physical properties, all the physical processes happen in the sun's atmosphere. So such a things happen, and we have a very good computation facility at Cambridge University Law. So we can do better model up to 2.5 solar years. These are different images of the sun. Of course, I want to discuss in these 30 seconds about the career plan of the engineering and science student, whatever you people are coming from the master's background. So for opportunity in ISRO, private sector, international collaboration, and academic and research, all the equipment, all the instruments are integrated in ISRO laboratory. So you can notice how big laboratory is there. When you have you will have any chance to visit the ISRO headquarters at Bangalore, as well as the ISRO laboratories in different part of the country, like Thiruvananthapuram, like VSSC Baba, Vikram Sarabhai Space Center. So from one laboratory to another laboratory, the rocket is different. Rocket is separated. Rocket means PSLV, as well as our instrument, our spacecraft, like Aditya L1 is in designing the different laboratory. So we need to assemble, integrate at one place, and then moving from laboratory to the launching site, launching pad. So these people are working how to integrate all the 7 payloads on board the Aditya L1, and this truck is already there were the cycle in 1962, and now we have a good facility to moving our satellite from one laboratory to another laboratory. So these are our development actually from ground based to space based. So this is the green signal comes from the senior people who were late the different instrument, and this is the and the interesting thing is at that time on 2nd September the temperature is around 40 degrees at Bangalore. Bangalore is hot as compared to other place in India, and that people are actually waiting for launching our first solar big mission, which took around 15 to 20 years to design completely and launch. So this is Aditya L1 mission launched from Sriharikota on 2nd September 2023. After long waiting, even my PhD was done on Aditya L1 when I was joined in 2017 July to doing my PhD. But at that time, the people get more time to elaborate more and check all the equipments, all the instruments on board the Aditya L1, and it will spend 5 to 6 years. And at last, they were launched in 2023. And this is really very interesting and historic mission. So foreign industry also looks for the data taken from Aditya L1. So this is the method, this is the technique how our satellite is launched. So you can notice here our satellite is going above the dense atmosphere of the Earth, and then it is like just throw with some constant velocity, and after constant velocity there is one thrust back side on the satellite, and it will it is basically creating some thrust, and it moves around the Earth and increase the velocity, and when it increase the velocity at a critical level, then it just go towards the 11 point. So this is basically how our launch the Aditya L1. This is the Aditya L1, and this was the upper part of our PSLV. Whatever all the other parts are ejected, isolated, because we don't need we don't need to keep all the parts above the dense atmosphere, because we need to spend much more energy. So this all about the Aditya L1, and yeah, thank you so much. These pictures I was project, so you can identify this. This is the main place. Whatever after launching, the director of ISRO, like Somnath, Professor Somnath, and current director also, who were clear at this moment. So I was, moving, 3 to 4 times at ISRO, visiting several times to engage in a meeting during the Aditya L1 and it all. So we need to talk properly in a scientific way. What about our mission, what our contribution, what we can do, the scientific idea, how can generate, how can improve our scientific idea before the launching. So this photograph is
डॉक्टर बलवीर जी ने बहुत अच्छे से हम लोग को आज अंतरिक्ष, सूर्य, ग्रह, उपग्रह और आधुनिक ज़माने में क्या बदलाव है उसके बारे में बताया। रिफ्रेशमेंट टाइम हुआ और फ़ोटो क्लिक हुआ और फिर हम लोग चले।